This here are the nodes for Pascal's triangle. So for here it says Pascal's triangle is a pattern of numbers that was discovered in the 13th century by French mathematician Blaise Pascal. Each number in Pascal's triangle is the sum of the two numbers diagonally above it. All outside numbers are 1. Complete rows 4 and 5 of Pascal's triangle. Okay, so pretty much like the first row is 1. Like you can't do anything about that. Then it says all diagonals are 1. So I could literally say this is 1, 1, 1, 1. And then this would be 1 as well. And this would be 1 as well. And on the other side as well. So you start at the top 1, go to the right 1, 1, 1. And this would be 1 and this would be 1. That's the one that says each number in Pascal's triangle, all outside numbers are 1. So that's what I just did there. Now this next part says each number in Pascal's triangle is the sum of the two numbers diagonally above it. All right, so what this says is like, so my diagonals above this one would be 1 plus 1, which is 2. 1 plus 2, which is 3. 2 plus 1, which is 3, and so on. So I'm trying to find this one right here. 1 plus 3 is 4. And the next number, 3 plus 3 is 6. And 3 plus 1 is 4. And the next one, you would do the same thing. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And then 4 plus 1 is 5. And the 1 is already there. Now, one thing you may also notice is that these numbers right here, it goes 1, 2, 3, 4, 5, and on the other side does the same thing as well. So that's like another pattern I see. Okay, now the next part says consider the binomial expansion of a plus b to the nth power. So for the first one, a plus b to the 0 power is equal to 1, which makes sense because anything raised to the 0 power is going to be 1. Now a plus b to the first power, right? If it's raised to the first power, we can literally just drop the parentheses, and then that would actually leave us with a plus b. Now, one thing I do want to point out is that, so the first one says anything raised to the first power is 1. For the second one, a plus b, it raised to the first power is just a plus b. If you think about the coefficients for a plus b, that's going to be 1 and 1. Now, a plus b squared is like taking a plus b times a plus b, and when you FOIL it out, you get a squared plus 2ab plus b squared. Now, if you think about the coefficients here, we would have 1, then 2ab would just be a 2, and then b squared would be ab. Okay? And then from here, we keep going, a plus b cubed. Like, if you can write it out 3 times, a plus b times a plus b times a plus b, or there's this formula here. And again, this last one, I'll show you just the coefficients here. A cubed, the coefficient is 1. 3a squared b, we have a 3. Plus 3ab squared, we have another 3. And then plus b cubed, we have a 1. And hopefully, if you take a look at the next ones, you'll start seeing the pattern of the coefficients. And hopefully, you see that they are creating the Pascal's triangle. So consider about what do you notice about the coefficients? The coefficients, when raising to a power, create the Pascal's triangle. All right, and this can be used just to, so the Pascal's triangle is used to kind of expand binomials, right? So we're going to call this first one here. Let's see. Let me go. It's going to be called row 0. The second one is going to be called row 1. And if you're curious, row 0 relates to this power right there. Right? And then row 1 relates to this power. So hopefully you realize the second one, the third one is going to be row 2 because it's related to the second power. Then we have row 3, row 4, and row 5 should relate to the 5th power. So hopefully you're seeing those powers related to each row. So, and it makes sense because row 0 means the power is 0. So anything raised to the 0 power is automatically going to be 1 regardless of anything. Okay. So let's talk about how to use the Pascal's triangle to expand these binomials. Okay, so the first thing we're going to do, and I'll kind of relate this one here, we're going to first look at, make sure it's a binomial, x plus 2 is. Then we're going to look at the power. So the degree here is 4. That means we're going to use the fourth row in terms of the pattern. Now, you notice they only use a plus b, so for us, this x is a, and this 2 is going to be our b. Okay? And then we're going to follow the pattern of this one. So when I look at this row 4, so it's kind of like right here. So let me bring these notes up. So we're actually looking at this row right here. That's row 4 for us right there. So the first thing I want to do is I want to take those coefficients 1, 4, 6, 4, 1. I'm going to write them down. So 1. And now I'm going to put 2 parentheses because if you notice this, we have like A and B. So 2 sets of parentheses, plus our next number was 4. We're going to put 2 sets of parentheses, plus 6, and then 2 sets of parentheses, plus 4 with 2 sets of parentheses, plus 1 with 2 sets of parentheses. Okay, now, so first off, let's kind of talk about this. We have the coefficients 1, 4, 6, 4, 1. And again, that just comes from here. 1, 4, 6, 4, 1. Now you're probably asking yourself, what are these spaces here for, right? So these spaces here are going to be for my A and my B. Because if you look at the formula above, there's A and B's in each one. Okay, so the first one's going to be X's, because that's my A. And my second one's going to be 2, because that's my B. We're going to put that in each one, X and 2. All right, so we have X and 2 for each one. Now, if you look at the pattern right above in the one arrow I pointed to, row 4, you'll notice the powers for A, they start at the actual number, 4, and then they decrease by 1 as you go to the right. 3, 2, 1, and then there's none, so which is 0. So we're going to start here. We're going to do this X to the 4th, 3rd, 2nd, 1st, and 0. Okay. Now, with the second numbers, you'll notice it actually goes backwards. So the second one here is B. So it goes 4, 3, 2, 1, and then 0. So here we're going to start at the 2. We're going to go 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and then 0. Okay, now we do have a polynomial here. And each one of these is considered a term. And in this term, all these are going to be multiplied. So we're just going to work it out one piece at a time here. So let me do some different color. So now here we have 1. Then we have x to the 4th times 1. For the second one, there's a plus sign. Then we have 4. X to the 3rd is x to the 3rd. And then 2 to the 1st power is 2. And for my next one, we have 6. X to the 2nd power is x squared. And notice the dot in between means multiplication. Then we have 2 squared, which is 4. Then we go to our next term, plus 4. X to the 1st power is just x. And then 2 to the 3rd is 8. Plus 1. We know that anything raised to the 0 power, so x to the 0 power is 1. And then 2 to the 4th is 2, 4, 8, 16. And the last thing we're going to do now, we're just going to simplify it. We're going to multiply them. And this will give us our final answer. So for the first one here, 1 times x to the 4th times 1 is x to the 4th. Plus, here, 4 times x cubed is 4x cubed. Times 2 is 8x cubed. And I put a plus sign here, but remember, it could change if there's like a negative. 6 times x squared is 6x squared. 6x squared times 4 is 24x squared. Right now I'm right here. 4 times x is 4x. 4x times 8 is 32x. And then we have 1 times 16 is a positive 16. So that gives us x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16 as our expanded binomial raised to the 4th power using our binomial of x plus 2. Okay, and I'm going to repeat this pattern as I go through. It's the same thing over and over again. Just got to memorize this triangle here, and it's pretty easy to create on your own. It's got to remember it starts at row 0, then you go 1, 2, 3, 4, and up to row 5. Okay, so for this next one here, let's go ahead and change the color. Let's go with green. Okay, so for here, hopefully you see that our row is row 5. So usually what I would do, I'll go back up here, and I'm using this row right here, row 5. Okay, so we'll start with the coefficients, 1, 5, 10, 10, 5, 1. And this time I'm just going to write it 1, 5, 10, 10, 5, 1. Now you notice the spaces I'm leaving, because now we're going to put spaces for A and B, and they're separated by plus signs. So the reason I like to put the parentheses first is just so I can work with the spacing. But here I just showed you how you could do it. And then we have 2 more parentheses here. All right, now we're going to go back to our problem. We're going to identify A and B. So A is the first term, B is the second term. So it's going to be x followed by 3. Negative 3. X followed by negative 3. So x, negative 3, x, negative 3. And we're just going to fill in each one of these with x first, then negative 3 second, all the way through. Okay. Now, if you remember from last time, we started 5 for x, the first term, A. Then we go down by 1 power. So 5, 4, 3, 2, 1, 0. And then to go backwards, we start negative 3 on the right side at 5, then we just go backwards. 5, 4, 3, 2, 1, and 0. Now, one thing I would tell you this is when you have a polynomial and you're looking for the degree, so this is degree 5th power. So that means that these 2 numbers right here, this one here and this one here, are supposed to add up to that 5. And they do. 5 plus 0 is 5. If you look at the next one, 4 and 1, 4 plus 1 is 5. 3 and 2, 3 plus 2 is 5, and so on. They all add up to 5. Okay, just like before now, we're going to simplify it one at a time. So for the first one, we have 1 times x to the 5th is x to the 5th times negative 3 to the 0 power is 1. Plus, the next one is 5. X to the 4th times is x to the 4th times negative 3 times 1 is negative 3. Plus 10. X to the 3rd is x cubed. And negative 3 squared is positive 9. Plus 10. X to the 2nd power is x squared times, and negative 3 cubed is negative 27. Plus 5 times x to the 1st is x. Negative 3 to the 4th, I want to say, is positive 81. Plus 1 times x to the 0 power is going to be 1. And negative 3 to the 5th power is going to be, I want to say, negative 243. Right now, from here, we're just going to simplify it. So each term one at a time. So right here, 1 times x to the 5th times 1 is x to the 5th. 5 times x to the 4th is 5x to the 4th. Times negative 3 is going to be negative 15x to the 4th. For my next one, 10 times x cubed is 10x cubed. Times 9 is 90x cubed. And then 10 times x squared is 10x squared. Times negative 27 is negative 270x squared. And then 5 times x is 5x. And 5x times 21 is 405x. And then the last one, 1 times negative 243 is negative 243. So this is my expanded binomial to the 5th power. X to the 5th minus 15x to the 4th plus 90x cubed minus 270x squared plus 405x minus 243. All right, and then we got our last one here, and this one is going to be raised to the third power, which is right here. So for this one, I go back up. I'm looking at this one right here. 1, 3, 3, 1. That's row 3. Right there, row 3. 1, 3, 3, 1. So I'm going to start with 1, 2 parentheses, plus 3, 2 parentheses, plus 3, 2 parentheses, plus 1, 2 parentheses. And I'm going to verify that is correct. 1, 3, 3, 1. Just to verify it, 1, 3, 3, 1 is correct. Okay. Now we go over here. This is A and this is B. So we have first one is 2C, second one is 5D. We're going to put those in each one. Now from here, we start from the left side. The first term, the 2C, we start with the power, the degree of 3. And then we just go down one every single one. So 2C cubed, 2C squared, 2C to the first, 2C to the 0. Now we get it to the 5D at the very far right. We start with 3 and we go backwards. So 3, 2, 1, and 0. All right, from here, this one you do have to be careful. You should work them out fairly slowly to make sure you do get them right. Okay, so over here we have 1 times. Now I'm going to show my work here. Remember, this is power to a power. There's 2 terms in here, so it's 3 times 1 is 2 to the third, times 3 times 1 is C cubed, times, and 5D to the 0 power, since all raised to the 0 power, that is 1, plus 3, and again here, you're going to, now I'm just going to square it, right? We're doing each one squared, so 1 times 2 is 2, 2 squared is 4, and then 1 times 2 is 2, so that's C squared. And then 5D to the first power is 5D. Plus 3. Now, 2C to the first power is just 2C. That will not change. But this one's different. We square each one. So 2 times 1 is 2. And 5 squared is 25. And then 1 times 2 is 2. And that's going to leave me with D squared. Now this last one, plus 1. 2C to the 0 power is automatically going to be 1. And this one, we're going to cube each one. So we're going to raise times that to 1 and times that to 1. So 3 times 1 is 3. So 5 cubed is 125. And then 1 times 3 is 3. So that is D cubed. All right, just like before, our last step is going to be always to simplify. So for this one here, 2 cubed is 8. So 1 times 8 is 8. 8 times C cubed is C cubed. Or 8C cubed, and 8C cubed times 1 is 8C to the third power. For this next one here, 3 times 4 is 12, times C squared is 12C squared, times 5 is 60, times D, so this is plus 60C squared D. And for this next one, again, you might just want to multiply the numbers. 3 times 2 is 6, 6 times 25 is 150. And then C times D squared is CD squared. And then last, 1 times 125 is 125. D to the third power. And this is my final answer. All right, and you might want to review this. And that's it for the notes.